So let's start the mass and weight unit in a little bit more in detail. So mass is defined as a measure of the amount of material of an object, and it is represented by small m, and its SI unit is kilogram and represented by kg. Metric unit is gram, represent as small g. But in the weight, the definition of weight is a measure of attraction between the sample and the gravitational field. So mass never change, but weight can be changed, because weight is a multiplication of mass, and g is gravitational acceleration. So on Earth, gravitation force is different than the moon. So if you weigh 100, if your mass is 100, and then the weight on the on the Earth will be multiplied by g of Earth, which is 9.8. So your weight will be like 98 kilogram. But in the moon, the g is less than Earth, so weight on the moon will be less. So this is the difference between the mass and weight. And then let's talk about the temperature. So temperature is a measure. What it measure? It measure basically hotness and coldness of an object, which determine the direction of the heat flow. So just like water flows from the higher height to the low downward, similarly heat flows spontaneously from an object with a higher temperature to an object with a lower temperature. So if we touch any hot pan, so basically we feel very warm or very hot, because pan on the gas is very high temperature and our body is low temperature. And there are 3 scales used to measure the temperature, and so they are, I will show you with this graph. So there are 3 scales, which is called Kelvin scale, Celsius scale, and Fahrenheit scale. So Celsius scale is based on the water. Water freezes at 0 degrees Celsius and water boil at 100 degrees Celsius. So this Celsius scale depend on the water property, and then Kelvin scale is based on the gas properties. So it starts from 273 kilo and end up 173 kilo Kelvin, sorry. And then there is another scale which is called Fahrenheit. So Fahrenheit usually don't use in the scientific measurement, but it is used, you may know, the weather report and body temperature. So weather report and body temperature is explained based on the Fahrenheit scale. So let's talk about a little bit more about these. So Celsius scale is based on the properties of water, 0 degree freezing point of the water and 100 degree boiling point of the water. And Kelvin is based on the properties of gases, and there is no negative value in the Kelvin temperature. And the lowest possible Kelvin temperature is absolute 0, which could be like a 0 Kelvin. So you can see in Kelvin scale there is no negative scale. It can go below 273 Kelvin, but it could be 0 Kelvin, but that temperature is like hypothetical. It never reaches at 0 Kelvin. So it's like that is why it's called absolute 0. And Fahrenheit scale used to measure the weather and body temperature. So this was about the temperature and mass. So let's see if we need to convert these different scales into one to another, how we will use the conversion, temperature conversion. So Kelvin and degrees Celsius can be converted by using this formula. Kelvin is equal to 0 degrees Celsius plus 273.15, and if we have to convert degrees Celsius and Fahrenheit, so if you know the Fahrenheit temperature, you can place it in this formula, and you can find the degree Celsius temperature. If we want to know the Fahrenheit temperature from degree Celsius, so we have to use these formula. So basically it's it would be better if you memorize. Usually that'd be really good. So let's take an example. If we have to perform a following conversion, 72 Fahrenheit to degree Celsius and Kelvin, so how we will do it? So first we will convert degree Celsius. First we will find degree Celsius. So as per the formula, degree Celsius is equal to 5 upon 9 multiplied by Fahrenheit temperature minus 32. So we can place this 72 degree Fahrenheit in this formula, and then minus, subtract it with the 32, which will come 40, and then multiplied by 5 divided by 9, which will come 22.2 degrees Celsius. So 72 Fahrenheit is equal to 22.2 degrees Celsius. And if we have to convert 22.2 degrees Celsius into Kelvin, we have to add this Kelvin temperature, degree Celsius temperature, into 273.15 value. So just place this value here and add this one. So at the end, when you will calculate, so Kelvin would be 295.37. So this is the simple example how will you convert any temperature into either Kelvin or Celsius or Fahrenheit. So let's talk about the next part, is the energy. It is in a very brief description, but in a very detail we will study in the thermodynamic chapter. So energy is as we have seen earlier in the video, energy is two types of energy. One is kinetic energy and another is potential energy. So kinetic energy is calculated, or you can calculate by this formula, which is half mv square, where m is a mass and v is a velocity. So if any object is moving, if any object which has a mass and moving with the certain velocity, we can calculate the kinetic energy using this formula. And the unit of energy is joule. It's represented by J, and kilojoule is commonly used for chemical analysis changes. So this was about the energy, and then let's talk about the another unit, which is called volume. So volume is a derived unit from the SI units. So quantity of the space occupied in three-dimensional space. So whatever the quantity is occupied in a three-dimensional area or space, that is called the volume. So it's usually measured in the 1 ml, or 1 ml is also called cubic centimeter. So cubic centimeter means it can be represented like, it represents like 1 cc, or you can also say 1 centimeter cube. And so as I said, volume is a derived unit from SI, and because it has length, it is derived from the length. So when we multiply by length in 3 times, so meter, which is meter cube, so this represent as a volume occupied. So unit of the volume are in the liter or in the millimeter, and 1 liter is a cubic 1 decimeter on each side, long on each side, and 1 ml is a cube of 1 centimeter long on each side. So here this represent this box which have 1 centimeter length, 1 centimeter width, 1 centimeter height. So this cube, which is 1 centimeter on each side, length, width and height. So when we will multiply 1 by 1 by 1, so the volume of this 1 centimeter cube will be equal to 1 ml, or we can say 1 cc or 1 centimeter cube. So similarly, if we have a space that is called decimeter, dm is a decimeter, multiplied by decimeter, then that will be equal to 1 liter. So decimeter means 10 centimeters. So in your lab, when you will go to the lab, you will use or you will see this kind of apparatus which are used in the laboratory, like graduated cylinder. You will use like it could be 50 ml from starting from 0 here and 100 here, or 50 ml here, or 100 ml, or 10 ml, or 25 ml. Similarly, syringes are also graduated, how many mls you want. And then this is a burette which also give you some volume, and then the pipette, and then this is a volumetric flask. So these kinds of glass apparatus or plastic apparatus you will use in your laboratory to measure the volume for your practical experiments. So let's talk about the next derivative unit, which is called density. So density means what is the density of a substance is its mass per unit volume. So density means how dense any subject is. If you throw a nail or block of iron or a rock in the water, it will submerge in the water. But if you will throw a wood stick or wood, it will float on the water. So why? Because rock or metal block or nail have a higher density than the water, that is why they sink. But the wood have a less density than the water, that is why it will float. So how we will calculate the density? Density is calculated by mass over the volume, and its unit is mass unit is a gram and volume is in the ml. So we can say gram per ml or gram per cc or gram per centimeter cube also. So let's take an example. If we have to weigh a water, a container that contain a 10 ml of water on the balance, which is shows 10 gram. But if we take 10 ml of mercury, which is a metal, liquid metal, and if we will balance weigh this on the balance, it will weigh as a 136 gram. So what do you think, this water has more density or the mercury? Which one has the more density? Yes, you can pause this video and think about. So you can calculate also which one have more density by putting these value in this formula. So 10 gram divided by, so water have density about the 10 gram by 10 ml. So like water has a density of 1 gram per ml, right? Like this one. And if we will calculate the density of the mercury, so mercury density have 136 gram divided by 10 ml. So it has a 13.6 gram per ml. So this shows that mercury is more dense than the water. Mercury is almost 13.6 times more dense. It has more density than the water. So this was about the density and volume. Let's take few more questions for practice. So an example, practice example. So a sample of carbon tetrachloride, a liquid carbon tetrachloride is also written like a CCl4. Tetra means 4, C is carbon and Cl is for chloride. So CCl4, a liquid once used in a dry cleaning, has a mass of this much gram and a volume of 25.0 ml. What is its density? So how we will calculate? So first we have to find out what are the values are given in the question. So mass of the CCl4 mass is 39.75 gram and the volume is 25 ml, and we know the density. How we will calculate? So density is equal to mass over volume, so we can just replace these value over the mass and the volume. So mass is 39.75 gram and volume is 25.0 ml. We have to just divide these values using calculator, or you can do by manual. Then you will find 1.59 gram per ml. It's very simple. And then let's talk one more question. Example 2 is the density of a magnesium, which is a metal Mg, is 1.74 gram per centimeter cube. So what is the volume of 275 gram of this metal? So if we have 275 gram of the metal which has density of this one, how much volume it will occupy? So we can still calculate from the same formula. If we know the density, we can calculate, and we know the mass, then we can calculate the volume. So out of 3 parameter, if you know any 2 of these, we can calculate one of them. So density is equal to mass over volume, so we can rearrange this formula. That volume can go up and density can go down on this side. So volume will be equal to mass over density, and now we can just place the numerical values into this formula. So mass would be 275 gram and density is equal to 1.75 gram per centimeter cube. So gram will be cancelled out, and then when you will calculate this, the value will come 158.05 and then centimeter cube. So this is the volume of the magnesium. So this was all about this topic about the units, and if you have any question, just type your comments here.